Hello dear students, today we are going to start with a new subtopic, equidistant points under distance formula. This series also has been divided into two parts, the first of which will be done today. The word equidistant here can be broken into two parts as equi and distant. Equi means equal and distant means distance. So today we are going to deal with points which are at equal distances from any 2 points on a Cartesian plane. So as you can see, a representative figure is here where we have 3 points A, B and in the middle P. So here the distance of AP, that is the distance from A to P, and the distance PP, that is distance from B to P, if they are equal, then we say P is equidistant from the points A and B. Hence, we will have AP equals to BP. Or in other words, the point P here is at equal distances from point A and B on a Cartesian plane. The learning objectives for the day are: first, we will examine the distance of points on a Cartesian plane from the coordinate axis, that is the x-axis and the y-axis. And then we will apply distance formula to inspect the elements of equidistant points, the coordinates or the elements of equidistant points. Let us now inspect distance of a point from coordinate axis. First, distance of a point from x-axis will be equals to the absolute value of y-coordinate. We will be taking the absolute value or modulus since distance is a scalar quantity. That is, we are only talking about magnitude. So for that reason, we will only be taking the face value of the y-coordinate. So the modulus sign is there. If in case we get a negative coordinate, we are only going to take the face value of it. X-axis being the horizontal axis, the distance of any point from it will be the vertical distance, the distance which is parallel to y-axis. Similarly, distance of a point from y-axis, the vertical axis, will be equals to the absolute value of x-coordinate, the modulus of x-coordinate. Since y-axis is the vertical axis, so the distance of any point from the vertical axis or the y-axis will be the horizontal distance, the distance which is parallel to x-axis. Let us do a question now, and the question is, what is the distance of the point -3, 4 from the y-axis? The location of the point on a Cartesian plane is this. The value of x-coordinate is -3 towards the left, and the value of y-coordinate is 4. Since we want the distance of this point from the y-axis, which is the vertical axis, the distance of the point from the y-axis will be the horizontal distance, distance parallel to x-axis. Since distance of point from y-axis equals to absolute value of x-coordinate, it will be equals to modulus of -3, since x-coordinate was -3. Minus means the direction was towards the left. But since distance is a scalar quantity, we will only be taking the magnitude, the face value. So modulus of -3 will be 3 units. The face value is 3. So distance of point from y-axis is equals to 3 units. Next question now. The question is, what is the distance of the point 1, 5 from the x-axis? The location of the point on the Cartesian plane is this. The value of x-coordinate is 1 and the value of y-coordinate is 5. Since we want the distance of this point from the x-axis, the horizontal axis, the distance of the point will be the vertical distance from the horizontal axis. So distance of point from x-axis equals to absolute value of y-coordinate. Since the value of y-coordinate was 5, so it will be absolute value of 5, modulus of 5. So 5 is a positive quantity, so there is no problem. It will be equals to 5 units. Distance of point from x-axis equals to 5 units. So the role of the modulus is to take only the absolute value, only the face value. The sign will not be considered. Minus or plus, it will not be considered. It will only take the face value. Let us now look at point on coordinate axis. First, point on x-axis. the horizontal axis, which is marked in green. As the point itself is on the horizontal axis, there will be some value of x coordinate. But since the point itself is on the horizontal axis, there is no vertical movement. So the value of y coordinate will be 0. Hence, a point on x-axis will be some value of x, y coordinate will be 0 since there is no vertical movement. Similarly, point on y-axis, the vertical axis marked in green again. Now, there will be some value of y coordinate as the point will lie on the vertical axis. But since there is no horizontal movement again, so the value of x coordinate will be 0. Hence, a point on y-axis will be 0, y. The question now, find the point on the x-axis which is equidistant from the 2 points 2, -5 and -2, 9. Figure now, we are considering the points as a and b, a 2, -5 and b -2, 9. The point in the middle, since the point was on the x-axis, so we are considering it to be p x, 0. The value of y coordinate will be 0 as the point was on the x-axis. So we can say let px, 0 be equidistant from the points a 2, -5 and b -2, 9. So AP will be equals to BP. Distance of A to P will be equals to distance of B to P. Now, since we are talking about distance, let us use distance formula. D equals to root over x2 minus x1 whole square plus y2 minus y1 whole square. For AP, coordinate of P will subtract A, that is x minus 2 whole square plus 0 minus -5 whole square, equals to, now for BP, x minus -2 whole square plus 0 minus 9 whole square. Since there is square root on both the sides, we can cancel the square roots. Now we'll be left with x minus 2 whole square plus 0 minus plus 5. 0 plus 5, 5 square, equals to x minus plus, so the sign will change, x plus 2 whole square plus 0 minus 9 whole square. Now let us use these identities. X minus 2 whole square is in the form of a minus b whole square. So a square, that is x square, minus 2ab, so minus 2 into x into 2, plus b square, so plus 2 square. Plus 5 square was already there, so let us just bring it down. Equals to x plus 2 whole square is in the form of a plus b whole square. So a square, that is x square, plus 2ab plus 2 into x into 2 plus b square, so plus 2 square, plus minus 9 whole square. Remember, quantities with similar signs and identical values on either side of equals to can be cancelled. Same quantity with identical sign on either side of equal to can be cancelled. So x square, it can be cancelled. Same quantities with identical signs. Similarly, plus 2 square, same quantity with identical sign can be cancelled. Let us now compute rest of the things. Minus 2 2s are 4 into x minus 4x plus 5 5s are 25. Onto the right side, 2 2s are 4 into x, 4x plus minus into minus plus 9 9s are 81. Now let us bring variables on one side and constants on other side. Minus 4x, the other 4x we are bringing from right to left, so the sign will change. Minus 4x equals to 81. 25 we are taking to the other side, so minus 25. Minus plus, but sign will remain minus. 4 plus 4, 8 minus 8x equals to 81 minus 25 will give us 56. Now x equals to, minus sign will also go to the other side, and 8, since it was in product, it will divide 56. 8 1s are 8, 8 7s are 56. So the value of x is minus 7. So we got the value of x. The question was not to find the value of the coordinate but the point. So we need to conclude our answer like this. Hence the required point is p minus 7, 0. The value of x coordinate is minus 7, and since the point was on the x-axis, the value of y coordinate will be 0. So the required point is p minus 7, 0. Next question is, Find the values of y for which the distance between the points p 2, -3 and q 10, y is 10 units. The given points are p 2, -3 and q 10, y, and the distance is given to us as pq equals to 10 units. Using the distance formula, under root x2 minus x1 whole square plus y2 minus y1 whole square equals to 10. So coordinates of q will now subtract coordinates of p. 10 minus 2 whole square plus y minus -3 whole square equals to 10. Now since there is square root on one side but there isn't square root on the other side, so we cannot cancel them. Now in order to remove that, let us square on both sides. So under root 10 minus 2 is 8 square plus y minus the sign will change, y plus 3 whole square, and we have squared that quantity equals to 10 square since we are squaring on both sides. So the square will cancel the square root from the left hand side. So the quantity that will be left will be 8 square plus y plus 3 square. The square root has been removed by the square equals to 10 tens are 100. So now let us expand the quantity. 8 8s are 64 plus y plus 3 whole square is in the form of a plus b whole square. So a square, that is y square, plus 2ab, 2 into y into 3, plus 3 square, that is b square, equals to 100. 64 plus y square plus 2 3s are 6 into y, 6y, plus 3 3s are 9 equals to 100. Now y square plus 6y plus 64 plus 9, 73 equals to 100. Let us bring 100 to the left hand side now to form a quadratic equation. Y square plus 6y plus 73 minus 100 equals to 0. Now the subtraction will give us y square plus 6y minus 27 equals to 0. So we have got a quadratic equation now. Let us solve this quadratic equation to get the values of y. In order to solve this equation, we need to factorize 27 into two parts such that the sum or difference can give us 6. So the two factors can be 9 and 3, as 9 3s is 27 and 9 minus 3 results in 6. So we can split the middle term like this: y square plus 9y minus 3y minus 27 equals to 0. 9y minus 3y gives us 6y. So from the first group, first two terms, first group, we can take y as common. So we will get y into y plus 9. From the second group, the last two terms, minus 3 can be taken common. So 3 into y is 3y, minus we have already taken common, so signs will be opposite. 3 9s are 27 equals to 0. Y plus 9 is common, so we will take that as common, and the quantities that will be left in the other bracket will be y minus 3 equals to 0. So y plus 9 into y minus 3 equals to 0. Since the product of these two is resulting in 0, either of them has to be 0. One of them must be 0. So either y plus 9 equals to 0 or y minus 3 equals to 0. Now in order to get the values of y, we will shift the constant to the right side. So y equals to plus 9 to the other side, it will be minus 9, and y equals to minus 3 to the other side, we will get y equals to 3. So the two values of y are y equals to minus 9 and y equals to 3. So this is our answer. These are assignment questions for you, which are similar to the ones which we have discussed in the video. Hint for the second question is given, as the point is on the y-axis, so the point will be 0, y. So use the hint and try to solve the question. And if there are any doubts, let us discuss. Thank you and have a nice day.